Hello my esteemed viewers. In this tutorial, we continue with machine learning fundamentals, and in this tutorial in particular, we will clearly explain as to what do we mean by well-posed problems which machine learning algorithms would attempt to solve. And summary of machine learning discussions that we went through in the previous tutorials is just this. Machine learning addresses the question of how to build computers that improve automatically through experience. Here experience means data, and we recall that as far as human beings are concerned, it is experiential learning, and as far as machine learning is concerned, it is through data. Data will provide kind of an experience for machines. Recent progress in machine learning has been driven both by the development of new learning algorithms and theory and by the ongoing explosion in the availability of online data and low-cost computations. Machine learning is a discipline focused on two interrelated questions. How can one construct computer systems that automatically improve through experience? And how to solve new problems which was not seen by the machine earlier. For a question as to whether machine learning, where exactly machine learning lies, for this the emphatic answer is it lies at the intersection of computer science and statistics, and it also lies at the core of data science and artificial intelligence. Machine learning solves only well-posed learning problems. Well-posed learning problems will never come with tailor-made algorithm. It's a practical problem. It may be a real-world problem. It may be it should be a very sensible problem, and it should be a feasible problem. And it is not based on first principles. It just comes just like that. Maybe in e-commerce domain, maybe in science and technology domain, maybe in mundane life domain, maybe from elsewhere. A well-posed learning problem was explained something like this. It's a computer program is said to learn from experience E in context to some task T and some performance measure P if its performance on T as measured by P upgrades with experience E. Though it sounds little rugged, but in simply, conceptually, machine learning algorithms can be viewed as searching through a large space of candidate programs guided by training experience, that is data, to find a program that optimizes the performance metrics. Of course, program is not written, program will be written by itself by the machine. Something like human beings. As human beings will start to solve a problem, they won't write a program. It just comes from the brain, from their experiential learning. The candidate programs could be decision trees, neural networks, and evolutionary computing algorithms, or mathematical functions, or whatsoever. Therefore, a well-posed problem will have three steps as to what task is to be done, as to what is the performance measure, and as to what is the experience that should be provided for a computer, for a machine. And we will go through at least 10 examples to reinforce our understanding regarding as to what do we mean by well-posed problem and categories of well-posed problems. Of course, this discussion is not exhaustive, and I always suggest my respected viewers to go through books and go through reference papers to find out a new problem that has already been solved by researchers in this fantastic domain. First one is detection of spam. There is no readily available algorithm for this. And here task is to classify emails as spam or not as spam. So it's a dichotomous problem. It's a dichotomous classification. We need to find whether an arrived email is a spam or not a spam. The performance measure for this particular machine learning task should be the fraction of emails accurately classified as spam or not as spam. So accuracy of classification is a performance measure. If the accuracy is high, definitely that particular machine learning algorithm would have done the task of classifying the emails. The experience is the data that is being collected by the programmer or by the machine learning expert. It may contain, it may be listing of unusual terms that are appearing, unusual links in the mail. Okay, and they will stand apart when in relation with usual terms and usual links that would arrive for a particular mail receiver, right? And the second example, a checkers learning problem. Of course, a machine learning expert has already been built years and years ago, which has beaten some of the authorities on checkers game, and the task is playing checkers game. Performance measure should be percentage of games won against the opponent. And how do you provide the experience? Playing implementation games against the machine itself by creating different scenarios with respect to the game player, a machine once again, and the movements and the board states and associated points that could be earned, and also the possible opponent's movements. So the experience provided for this particular machine learning problem should be different scenarios of movements, the board states, and the associated points that could be earned. Example 3 is a handwriting recognition problem. Here the task is acknowledging handwritten words within a portrayal, or identifying a letter or the word which has been formed out of different letters or different alphabets. The performance measure could be percentage of words accurately recognized or identified. Experience should be a repository or a directory of handwritten words with given classifications. Example 4, a robot driving problem. Task is driving on public 4-lane highways using sight scanners. Of course, a robot driving robot will essentially get the inputs by the sensors mounted on the car. It is like eyes for a human being. Performance measure could be average distance progressed before a fallacy, before a failure, before a misalignment, before a possible accident happened. Experience is order of images and steering instructions noted down while observing a human driver. Example 5, fruit identification problem. Here the task is recognizing different fruits. Apple and apple, classifying an apple and apple, or labeling an apple with apple, and a guava with a guava, grape with a grape, something like this. The performance measure is accuracy or percentage of identification. The percentage accuracy of identification, correct identification or correct classification. The experience is training machine with the largest data sets of fruits images, and a repository of features for different fruits, like size, like volume, like color, anything. Of course, there cannot be an exhaustive list of features. Okay, it is situation specific. Example 6, face recognition problem. The task is identifying faces of persons. Performance measure could be percentage faces recognized accurately. Experience is training machine with huge gallery of different face images of different people, with subsets of images of an individual like this under different facial expressions. This is a gallery of different people, and here individual people's gallery, that is subsets of a particular person with different facial expressions, different orientations. Right. Example 7, automatic translation of documents. The task is translating one type of language used in a document to other language. All these kind of tasks, whatever that I am giving examples, is taken from the literature or internet, and none of them has been discussed on a rule of thumb. Okay, all these problems have been ventured, and successful machine learning algorithms or machine learning exercises have already been done. Performance measure here is ability to convert one language to another efficiently, and percentage accuracy of correct matches of words. Experience is training machine provided with a large data set of different types of languages. Example 8. Leaf disease detection problem. Detecting the kind of disease in a leaf, in a given leaf. Of course, a leaf cannot be provided for a machine. Of course, it goes without saying that we are providing the images of the diseases leaves inflicted with diseases, and also the images of a normal leaf which has not been stricken by a disease. Performance measure could be accuracy of correct detection in terms of percentage test images correctly detected with regard to its disease. And continuing further, we can also develop a machine which will also detect the percentage of or the severity of the disease. Experience is training machine with a large image gallery of different leaves with different diseases, with a huge repository of features corresponding to different diseases. Different leaves, different kinds of leaves from different plants, and different kinds of diseases probably which may inflict. Example 9. Glaucoma detection problem. The task is detecting whether or not an eye image provided to a system is glaucoma inflicted. Performance measure, percentage accuracy in detection. Experience, training machine provided with a huge image gallery of normal eye images and glaucoma inflicted eye images with relevant features such as degree of redness, cup to disc ratio, and percentage constriction of annular space between disc and cup. Example 10. Ear recognition and personal identification. The task is detecting the identity of a person through his ear or through his or her ear image. This is ear biometrics. It's a big field of ear biometrics. Performance measure, the percentage accuracy in detection of persons given his or her image of the ear. Experience, training machine with a large image gallery of ear images and features like maximum length, maximum width, earlobe configuration, and there are different features marked over here. Okay, all these features are measurable and it can be provided, and these measurements are done over a given image. That is the beauty. And area of coverage, the area of coverage of this particular ear. See, all these examples, my dear friends, my dear viewers, has explained as to what a well-posed problem is, and while a machine addresses solving a well-posed problem, it does three processes. One is it has to identify itself as to what it should do. That is in the programmer's hand. And performance measure, how exactly the performance of a machine could be measured, and what is the data that you are going to provide, and the kind of data, the kind of features that we are going to provide depends upon the kind of problem that is being addressed by the machine learning exercise. So with this we will complete this tutorial, and this tutorial was meant to just to explain as to what well-posed problem is, that are solved by machines, as on this date, and several examples were given in order to reinforce our understanding regarding these well-posed problems. And before we come up with the next tutorial, which is once again the advanced version of fundamentals of machine learning, I would request, if you have liked this video, kindly subscribe to my channel. And until I come with the next tutorial, bye. Thank you.